Welcome to PalSaaLab, your destination for amazing discoveries in science, space, AI, and technology.
Every time a traditional rocket launches, up to $50 million can end up at the bottom of the ocean. Think about that. Imagine building a brand new Boeing airplane, flying it once, and then throwing it away forever. Sounds ridiculous, right? Well, that's exactly how spaceflight worked for decades. But then one company asked a simple question, what if rockets could come back? And the answer is changing space travel forever. Intro. 020 to 1 o'clock. Reusable rockets are one of the most important inventions in modern history. They are making space launches cheaper, faster, and more frequent than ever before. Companies like SpaceX, Blue Origin, Rocket Lab, and even emerging Chinese space companies are all racing to perfect this technology. But here's the incredible part. A reusable rocket doesn't just survive a trip to space. It flies back through the atmosphere, slows itself down, and lands upright with incredible precision. How is that even possible? Today, we're going to break down exactly how reusable rockets work, why they matter, and why they could be the key to humanity's future in space. Let's launch. Chapter 1. The problem with traditional rockets. To understand reusable rockets, we first need to understand the problem they solve. Most rockets are built in stages. The largest section is called the booster. Think of it as a giant fuel tank packed with powerful engines. Its job is simple. Get the rocket off the ground and push it through the thickest part of Earth's atmosphere. After a few minutes, the fuel runs low. The booster separates. And then it falls into the ocean. Mission over. For decades, this was completely normal. Engineers would spend months, or even years, designing these incredibly advanced machines. They contain sophisticated computers, precision-engineered parts, and some of the most powerful engines ever built. Yet after only about 90 seconds of useful work, they were discarded forever. Thousands of rocket parts now rest on the ocean floor. Not only is that wasteful, it's incredibly expensive. And that's exactly why the idea of reusable rockets became so important. Chapter 2. NASA's first attempts at reusability. Long before SpaceX became famous, NASA experimented with reusing rocket boosters. The Space Shuttle used two giant solid rocket boosters attached to its sides. After helping the shuttle leave Earth, they separated and deployed parachutes. Instead of crashing into the ocean, they floated on the water. Recovery ships collected them and brought them back to shore. The boosters could then be cleaned, refurbished, and used again. It was a clever solution. But there was a major drawback. Saltwater. Water damages electronics, corrodes metal, and increases maintenance costs. Engineers wanted something even better. They wanted rockets that could return directly to land. And that idea sounded almost impossible. Chapter 3. The impossible dream. Imagine balancing a pencil on your fingertip. Difficult, right? Now imagine balancing that pencil while it's falling from space at thousands of miles per hour. That's basically what landing a rocket looks like. For decades, many experts believed vertical rocket landings simply couldn't be done. The math was difficult. The engineering was extreme. The margin for error was almost zero. Yet SpaceX believed it could work. Instead of letting boosters crash into the ocean, they wanted them to fly themselves home. And that required solving one of the biggest engineering challenges in history: teaching a rocket how to land. Chapter 4. The Grasshopper Experiment. In 2012, SpaceX began testing a strange-looking vehicle called Grasshopper. It wasn't designed to reach orbit. Its purpose was much simpler. Take off. Hover. Land. Again and again. Engineers call these flights hops. At first, the tests were small. But each successful hop taught SpaceX something important. The rocket's engine needed to be incredibly precise. If the engine produced too much thrust, the rocket would shoot back upward. Too little thrust, and it would crash. The rocket needed to find the perfect balance. This became the first secret ingredient behind reusable rockets. Precise engine control. Without it, nothing else would work. Chapter 5. Why Falcon 9 uses 9 engines. One of the smartest decisions SpaceX made was using 9 smaller engines instead of a few giant ones. At launch, all 9 engines fired together to generate enormous power. But during landing, only one engine may be needed. This gives the rocket incredible control. Think of it like driving a car. It's easier to maintain a smooth speed using gentle pressure on the gas pedal than an all-or-nothing switch. As the booster gets closer to the ground, it becomes much lighter because most of its fuel has already been burned. A giant engine would still be too powerful. Smaller engines allow precise adjustments. And precision is everything when your goal is landing a 150-foot tall rocket upright. Chapter 6. The hardest part: restarting engines. Iodine mononitride mid-air. Here's something most people don't realize. Launching a rocket is only half the challenge. Landing it may actually be harder. Rocket engines are designed to start under carefully controlled conditions. A launch pad provides those conditions. Space doesn't. During descent, engines must restart while traveling at high speeds and under constantly changing conditions. If the restart fails, the mission is over. This is why many early reusable rocket tests ended in explosions. And yes, sometimes very dramatic explosions. But every failure provided valuable data. Each test brought engineers one step closer to success. In rocket science, failure isn't the opposite of progress. It's often part of the process. Chapter 7. The journey back to Earth. Now let's follow a Falcon 9 booster on its trip home. After separating from the upper stage, the booster is traveling at incredible speed and sits dozens of miles above Earth. The first step is turning around. Small thrusters near the top of the rocket fire bursts of compressed gas. These rotate the booster until its engines face the correct direction. Next comes the boost back burn. Several engines ignite. This slows the rocket and redirects it toward its landing site. Then comes one of the most dangerous parts of the mission: re-entry. As the booster crashes back into Earth's atmosphere, temperatures rise dramatically. To protect itself, the rocket performs another engine burn. This is called the re-entry burn. It slows the vehicle and helps push superheated air away from the rocket. The glowing exhaust creates what engineers sometimes describe as a protective shield beneath the booster. Without this maneuver, the rocket would face extreme heating and stress. Chapter 8. The secret wings. Oxygen monofluoride reusable rockets. As the rocket descends further, another fascinating piece of technology takes over. Grid fins. These metal fins unfold from the sides of the booster. Unlike airplane wings, they're designed specifically for high-speed atmospheric control. As air flows through them, they help steer the rocket toward its target. Think of them as the rocket's steering wheel. Meanwhile, onboard computers constantly calculate position, altitude, speed, direction, and weather conditions. Using GPS and advanced navigation systems, the rocket makes thousands of adjustments every second. No pilot is controlling it. The rocket flies itself. And it does so with astonishing accuracy. Chapter 9. The final landing. Now comes the moment everyone waits for. The landing burn. A single engine reignites. The rocket begins slowing rapidly. Faster. Slower. More precise. More precise. Then, just seconds before touchdown, the landing legs deploy. These lightweight legs lock into place and prepare for impact. The onboard computer continues making tiny corrections. The engine throttles lower and lower. And then, touchdown. A machine that traveled to space lands gently on a pad no larger than a small parking lot. It's one of the most incredible engineering achievements ever accomplished. Chapter 10. The future of reusable rockets, 1245 to 1400. Today, SpaceX leads the world in reusable rocket technology. But the competition is growing. Blue Origin is developing New Glenn. Rocket Lab is building Neutron. China is testing multiple reusable rocket designs. And SpaceX itself is working toward a fully reusable future with Starship. The goal is simple. Lower costs. More launches. More exploration. Because when rockets become reusable, access to space becomes dramatically cheaper. That means more satellites. More scientific discoveries. Moon bases. Mars missions. And technologies we haven't even imagined yet. Reusable rockets are doing for space travel what commercial airplanes did for air travel. They're turning something rare and expensive into something practical and repeatable. Conclusion. Just a few years ago, watching a rocket land itself seemed like science fiction. Today, it's becoming routine. And tomorrow? Reusable rockets may help humanity become a truly spacefaring civilization. The next giant leap for mankind may not begin with a new destination. It may begin with a rocket that simply knows how to come home. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more amazing space stories explained in simple English. Thanks for watching. And we'll see you in the next mission.